Good afternoon. We begin our afternoon session, TPM 4. My name is Gadi Golan. I'll be the chairman of this session. Okay, so I'd like to invite Dr. Yuval Beck from the Holon Institute of Technology. He'll speak about demand management in smart grid. Actually, Yuval is heading the power engineering department in the Faculty of Engineering in Holon. And he is one of the pioneers in power engineering in Holon and heading the smart grid initiative in Holon. Yuval?
I think it's also better that I'll do the first lecture because it's really very vague and general, so you'll probably get into more specific details. I'm actually giving today a lecture which is not normally what I do, which is, as I said, something more general. And what I wanted to show is, first of all, we opened at the Holon Institute of Technology a Renewable Energy and Smart Grid Excellence Center, which is a very interesting center, which in this center we have collaboration between staff member and students, and really try, because I think also in this lecture you will see that one of the problems with the smart grid, like we all here, probably if you're in the session, so you obviously know what is smart grid, but most of the population have no clue what we're talking about. So we wanted to start that a program that students, even in their first degree of engineering, will be able to come somewhere in the institute and will be able to experience renewable energy, smart grids, and also they can contribute. And what you see here is basically a contribution of students that we let them do surveys and search a lot of research and papers in various subjects. First of all, to define this lecture, the lecture is about a big name which is called demand response. And what you see here is a definition from the Federal Energy Regulatory Commission in the US. I'm saying who gave the definition because there's various definitions that you can find in many places. And what this definition says is that it's change in the electric usage by end-use customers from their normal consumption patterns in response to change in the price of electricity over time, or to incentive payments designed to induce lower electricity use at times of high wholesale market prices or when system reliability is jeopardized. This is like the big subject that we're talking about, is how to make changes with the consumers and to control the consumer, so we will also play a role in this big idea of smart grid. We have three elements that needs to be fulfilled so we can employ a smart grid. One of them is, first of all, we need a lot of data, and for that we need smart metering. And I think about the implementation of this subject, the next lecture will give more details and some more figures. Then we need to have the regulatory support, which means that the government or whoever is responsible to employ it, there needs to be some order, and I'll speak a little bit of that. And then I think the most difficult and less addressed by now, there's a lot of research done, but it's more difficult to anticipate how the consumer will respond to this type of thing. So if we'll talk about smart metering implementation, so there's a lot of functionality. What you see here is a lot of benefits that we collected from many research, many papers and many researches that we read. Not all of them are required at every country. It really depends on what is needed in that country. But some of the functionalities are, first of all, we want the measurements of consumption and production, and then remote steady reading by demand. There is a lot of talk about tariffs, like we want the ability to have historic consumption, comparative parameters display. We want measurements or load behavior graphs storage, if we want to make afterwards some analysis. We want remote connection and disconnection and load limiting. This is, again, it's a functionality that meters can give, but in many countries, and probably most countries, it's still illegal that the electric company will get into the end user and will connect or disconnect. In some places, even if it's allowed, the law doesn't allow to do this kind of things. Then we want remote firmware upgrade. One of the benefits of smart grid that we'll have a lot of meters, and we can, from remote places, we can upgrade the system. We want to transmit of power quality reports by standards if it's necessary in that place. Communication abilities with other meters, communication concentrators, other devices and appliances. We want to have the ability to do a prepay meters in countries like in South Africa and places that prepay bills are what is the normal system. Self-display and transfer of meter data to external displays such as iPad, tablet. We want to incorporate all these new technologies into the smart grid and make it part of our lives. What is the benefits for the producers? First of all, it enables what happens in Europe now these days, dynamic pricing. Since we have a lot of information on the consumption, we can do all this dynamic pricing. It gives you the ability to do some personalized tariffs, which mean in some cases, some industries, you can change the tariffs to their needs. Demand response services, you give the producer an ability not only to sell electricity, but also to give other services because they have all this knowledge. Then remote updating meters in minimum time, like with the normal meters, obviously it's impossible. Accurate data leads to less complaints by consumers. This is not always true, but at least some researchers saw that when you have a lot of accurate data, so basically the consumers will have nothing to complain about. Record management efficiency, which means that there's a lot of places there where electricity is not really paid by the actual consumption, and with the better metering system, this is now possible. Now, this is less applicable to Israel when we start about different types of producers, like we have here the DSO and TSO. In Israel, it's all in one company. But if you go more to the level of the distributing company that comes towards the clients, you can have, first of all, better data on consumer, which leads to better services and various services. The efficiency of the distributor system operation gets higher. You can have more ability and reliability and fault detection. You can have actually communication with your customers. You can have by SMS, radio, internet, can be a bidirectional communication about the data. Then you can have fast recovery time, losses and electricity theft. You can get information about electricity theft, phase and frequency monitoring, better management of network assets, smarter investments. Basically, the knowledge of a lot of data can give you a lot of opportunities for the company who wants to give smart grid services. There's other benefits, like if you go larger, if you want to incorporate the gas system, the electricity system, the water system, so you can have meters that can incorporate all this data and to have a multi-utility communication. And then there is a little bit of a problem is if one of the things that you see are like a consumer profile, that we can learn a lot about our consumers, then there is another issue of security and privacy. And when I'll get to the last section, when we talk about the consumers, I think most people will not want the electric company or whatever company who wants to give you services to know exactly when they came home, when they put the boiler on, and when they leave home. There is a lot of problem with that. And about security, again, it's a system now that you have a lot of penetration points that can be jeopardized. If you look here, you can see a system. So as I said, there is a lot of security issues that needs to be addressed. And this will be probably one of the key factors for a success smart grid, since I don't think any client will want to give all this data if the system is not secured. About the regulatory support. So to make smart grids safe and to, since we have the operator sides and the consumer side, some regulations needs to be done. The data here is taken from various pilots and various laws that were issued mostly in this research in the United States. What does regulations needs to support? First, enabling energy providers to make profit from additional smart energy services. Namely, that all the providers won't only sell kilowatt hours, since this system gives them a lot of opportunities to make profit not only from kilowatt hours, which will probably, if the system is efficient, will be a cheaper price. Allowed contracts for appliances and load automatic disconnection. As I said before, to make disconnection of appliances someone needs to issue a law. Return of investment policy. Exclusive ownership of consumer data by the consumer can give permission to third parties. So me as a consumer, I want the data to be the decision if to give my data to a third party. I want the consumer to have it. Implementation, smart metering at all consumer for maximizing the system ability. It has to be by some sort of regulation, so a system will be implemented. Standardization of smart metering. In every country it needs to be standardized. Net metering for prosumers. Aggregation demand for flat consumption. Here you have in this graph an example of aggregating two consumers with the same bill, because one of them has the peak load in the afternoon and one peak load at night. To make it more flat, they aggregate their consumption, and by that and they lowering their electricity bills. Also creation, supporting new programs and products, and give incentives to energy and infrastructure. Here we have some examples. I won't go in detail in every one. In the USA, this is programs, how much are invested there in California. You have about, between 2006 and 2008, about 215 programs for energy efficiency. $2 billion were invested, and 1,685 megawatts and 7,367 megawatt hour reduction was measured. Also they saved two generation unit of 500 megawatts. Then you have a 2010 and 2012 investment of 3.1 billion for reduction of 7,000, and it goes on. I won't go in all of them, but the important one is in Massachusetts, when they separated between the income from infrastructure to sales profit, which enables insertion of few generation companies with clients. Again, $120 million for financing demand response program. They passed the Green Community Act, which was the law for separation between the infrastructure and energy provider. There's a lot of public education which is done there. In Israel, unfortunately, it's not yet, but obviously we'll start it soon. Financial incentives for reduction of peak load and average consumption by 5%, energy pay and save programs which enable consumers to buy energy efficient appliances and pay to the infrastructure company in payments. In New York, again, separation between the infrastructure incentives and about 1,500 energy reduction projects. In Texas, they don't have any, they don't have to pay for the implementation of the smart meters. I don't know why is this in Hebrew. It wasn't supposed to. And the last part of the puzzle, as we said, we have the producers, we have the regulation, and probably the most problematic is the poor people who needs to accept it, which is the end-user response and acceptance. And before you put smart grids, you want to implement it, there's a few questions that need to be asked. What is the new services for the consumer? Every consumer will probably ask himself. Is the consumer interested in these services? Like, we want to convince the consumer that it's good for him, but he needs to understand if he wants this new smart grid and new benefits. And is the demand response will change its consumption habits? Why are people skeptic? Most research show that probably, first of all, it's from a misunderstanding of the technology. Today, I think, in Israel, definitely 99.9% of the population will say smart grid, they won't know what you're talking about. So nobody knows about it. And after you explain to them, they say, if now my appliances are working with computers and they can respond, so obviously it's some sort of science fiction. And everybody has a very bad perception of robots controlling humans. And the last thing, after you convince them that this is not so bad, then the privacy and security, which is important to all of us. I can tell you a little story. I think about 10 years ago, I was in a convention. It's a story about how sometimes to educate the population can take time. I was in a convention in South Africa, which was about global warming, and they had a session. In the break, I had lunch with someone from General Electric. They did in South Africa, in a very remote village, a power system based on wind power. And the problem was, first of all, they came in that village in Africa. It was a village belonged to a tribe called Zulu. And they have to come, first of all, to the chief of the village. And they ask him, we want to put electricity to your village. So he heard that the electricity is very, very good, but he needs to ask the question. He asked them, listen, there's about 2 kilometers from here another town. Do they get the electricity the same way you want to give us? So they say, it's the same electricity, but we do it different. We'll give you the wind. So then it took 2 months to convince him that first of all, to put the electricity with wind power. After they did it, they put all the system. It was one or two turbines, and the village had the electricity, and they had control over the village, and they saw that after very, very short time, the system collapsed every week. They cannot, it's overloaded, and they had to send someone. And you have to understand, to send someone there is not like you give him on the GPS, you go to this and this street. You need coordinates just to get there. They got there, and what was the problem? That's a question to the audience. No. That's education. This village, before they got electricity, was still in what we call the wood age, which means that they cook and get warm in the same fire, which, by the way, in the Zulu tradition, they do it inside the huts. And they have a very nice technology of the huts that the smoke comes out and doesn't stay in. But for them, cooking and getting warm was the same. What happened in that village? Everyone got ovens. They all opened the ovens, and everybody is sitting around the ovens. So the system collapsed. So it's not so far from what we hear. Like if we're talking about a system that controls appliances, most people, it's not that easy. There's a lot of research done on this subject, how to educate a population to accept it, but it's not going to be easy. From the research we read, the recommendations for, I called it recommendations for happy customers, is first of all to make sure that the consumers can benefit from the cost saving enabled by the smart grid in fair and appropriate manner. The government should take, or whoever, I said government, but it can be any organization that is responsible for that, should take ultimate responsibility for ensuring that the smart grid is secure. Honesty and transparency are key, and the consumer engagement is important to manage consumer concern. The more the customers will understand, it's probably going to be easier to implement it. Consumer must be able to make informed choices and have meaningful control over their data and its use. Research on consumer behavior is smart grid. There's a lot of research, and every place that needs to implement it should probably read a lot of research that was already done. And I think the most important is public education, commercials, and whatever that means. Thank you very much.